Have we started the recording?
Yes.
Okay, awesome. Hi, everyone. Good morning. A very warm welcome to all of you on this today's workshop of Terraform Unleashed, Harnessing the Power of Infrastructure as a Code. Thank you very much for joining us today. I really appreciate the enthusiasm, and I promise you take away lots of learning today. Now, let me quickly introduce myself. I'm Kinnari Sutaria, your guide on this Terraform journey today. With over 5 years of experience in the dynamic realm of IT, I've had the privilege of working with cutting edge technologies, and I have been part of the fantastic team at ThoughtWorks for the last 3 years. My expertise spans a multitude of cloud technologies, from AWS to Terraform, Docker, Kubernetes, and observability, among others. But what truly sets my journey apart is my passion for sharing knowledge with the community. I've had the honor of conducting multiple workshops, including building serverless solutions with AWS. I think some of you must have attended that too. I had done a session on Docker in a day, clustering with Kubernetes, and today's workshop is Terraform Unleashed, which marks my fourth workshop in the past year. And I can't wait to dive into this exciting world of infrastructure as a code with all of you. And beyond my tech savvy side, I'm an avid traveler, a thrill seeking in adventure sports, and a food blogger who balances it all with healthy dose at a gym. So let's embark on this incredible journey together where we'll all explore Terraform's limitless potential and I'll share my insights, experiences, and knowledge with you. Get ready for an enlightening and engaging workshop. I hope you all enjoy today's workshop. Moving on. So, I want like I want this workshop to be very interactive. We don't want it to be like a monologue, right? So I want everyone, whoever is possible, be on cameras. Keep yourselves on mute if you're not speaking. Raise your hands if you have any questions. Put your questions in the chat as well. We'll be continuously monitoring the chat too. And we'll make sure that we answer each and every questions of yours to the best of our capability. Okay. And yes, so folks, what are we going to do today? What are your expectations out of today's workshop? When you join today's workshop, you must have thought about some things, right? That this is what you're looking forward to. You'll be learning Terraform, basics of Terraform, getting started, hands-on. Uh, could you please tell me? We can have it on chat, or you can unmute yourself and speak as well.
Prerna has raised her hand.
Yes. So today I've joined this session because in my project I'm working on Databricks, and the Databricks capabilities we are leveraging IAC infrastructure as a code using the Databricks APIs provided by Databricks itself. And when I was using that, I had written a blog on it as well. So that how infrastructure as a code can be leveraged. Currently, it's the APIs, but I read that Terraform is also one. I don't know what to call it. Also, is it like a software platform tool?
It is infrastructure as a code, Prerna.
Okay. So all right. So I wanted to just explore how Terraform would play a role.
Awesome, awesome. Yes, definitely. We'll go through the Terraform and then maybe you can get an idea if you can implement it in your project or not. Sure. Awesome. What else? What others have in mind before joining this workshop? Can you put it on chat or you can unmute yourselves? Okay, no worries. We can proceed further. So, yes, over the next several hours, we'll embark on a journey to explore Terraform, a leading infrastructure as a code tool that has revolutionized the way organizations deploy, manage, and scale their infrastructure. We'll be first discussing a world without Terraform, the challenges it has, and then we will proceed to infrastructure as a code. Why, what, and how Terraform empowers us to treat infrastructure as a code, providing us with the agility to build, modify, and destroy resources with accurate precision and ease. As we delve deeper into this workshop, we will demystify Terraform's concept, understands its core principles, Terraform state, and its management, and further complex topics such as modules, and master the art of creating, configuring, and managing infrastructure as code. Now, who is this workshop for? Whether you are a seasoned DevOps engineer, a curious developer, or a curious QA, or you are someone who is completely new to the world of IAC, that is infrastructure as a code, this workshop is designed to cater to all skill levels. So fasten your seat belts as we take a deep dive into Terraform's capabilities and reveal how it can help you achieve infrastructure automation, increase productivity, and reduce the risk of human errors. By the end of our journey, you'll not only have a solid foundation in Terraform, but also a newfound appreciation for the transformative potential of infrastructure as code. So, let's talk about a world without Terraform. So, can you all tell me what are the, just imagine if there was no infrastructure as a code. So, how would it look like? What will be the challenges? Can you imagine that?
Hello, Sandeepan here.
Yes,
Yeah,
Sandeep.
yeah. So, in my last project, I mean, I have seen like DevOps team they use Terraform, right? So, as I understood from them, if there is no Terraform right now, so like for every environment they have to configure separately. They have to write code different. I mean, for every environment, it will be separate code, separate configuration they have to do. But using the Terraform, like they just need to change the few things based on the environment, like QA, dev, staging, prod. So it will be easy actually, and we can automate it easily using the Terraform.
Correct.
I mean, this much only I know from them.
Yeah, no
Mm,
worries.
yeah.
That's really good answer. Thank you.
Yeah.
Awesome. So, for people who don't know anything about Terraform, I'll start with a very easy, simple analogy. Okay. Let's use a real life. Today in the workshop, you'll be seeing me using a lot of analogies so that it makes easier for the beginner level people to understand what Terraform is, what infrastructure code is. So worry not. I'll explain in very layman terms. So if even if you have never heard about Terraform, you'll definitely start knowing a lot about Terraform. So let's use a construction site analogy. Okay. So imagine managing your IT infrastructure without Terraform is like building a complex structure using only hand tools or manual labor. You have a vast construction site with different components, including walls, electric system, plumbing, and more, each representing a piece of your infrastructure. Okay. So in this manual world, you are the chief architect and construction worker, and you must carefully measure, cut, and assemble every piece yourself. If you need any additional rooms or floors, you have to manually plan and construct them, which is very time consuming, right? And very error prone when you're doing all this manually. So each room represents a server or a resource in your infrastructure. So as we heard over here, right, that there will be so many challenges while doing this. So let's look at the challenges. The very first thing that comes to our mind is inefficiency, right? Building and maintaining each room separately will consume a significant amount of your time and resources. Inconsistencies. It is very difficult for a human being to construct everything in a similar fashion, right? The consistency cannot be maintained. It will be error prone. There is no blueprint. If someone else will come and work on that construction site, they won't know what the other person was thinking, right? Because there is no blueprint. Then scaling. If you want to scale 2 more floors or you want to scale down, if there is no people living in that building, you'll have to scale down. So how does that happen? All of this is very daunting task, right? So now let's talk about this in the terms of Terraform. Okay. In terms of IT, like infrastructure automation. Okay. So in infrastructure as well, like we had analogy for the construction site. Now let's talk in terms of infrastructure. So when you have your own infrastructure for your applications, if you're doing everything in the traditional way, that is the manual configurations way, you'll have so many challenges. Like like you'll have issues with the manual configuration, complexity and error prone, the scalability challenges, inefficiency, then the vendor lock-in. Now, what is vendor lock-in? As in, with the traditional infrastructure, you'll often have a vendor lock-in because you cannot migrate your infrastructure from one vendor to another vendor. But these are so many challenges, right? So, what do we do about these challenges? Wouldn't it be great if we had something which would automate all this, right? So, there comes the infrastructure as a code. So, infrastructure as a code is like advanced architectural software that allows you to design your entire structure in one comprehensive blueprint. We'll call it as a configuration files, Terraform state, and all those things. But don't worry, fasten your seatbelts. We'll go on that journey soon. So, infrastructure as a code will automate the construction process, making it efficient, error-free, highly scalable. When you need to add or remove rooms, you simply adjust the blueprint and everything will be taken care by the Terraform or infrastructure code as code itself. Isn't that wonderful? Yes, definitely it is. So let's go to the next slide. The solution is automating the infrastructure, right? So what is infrastructure as a code? Infrastructure as a code tool allows you to manage infrastructure with configuration files rather than through graphical user interface. You all must have went to the AWS console, Azure console, or GCP console and tried creating resources, right? EC2 instances, S3 buckets, DynamoDB tables. So you are doing all of that manually. But with infrastructure as a code, you will do all of these things with configuration files. You'll have simple TF files that you will be using for doing all of this. So isn't that great? Everything will be as part of the code itself. This approach streamlines infrastructure management. It reduces the risk of errors, enhancing efficiency, enabling organizations to respond more effectively to the dynamic demands of modern technology environments, whether in the cloud or on-premise. You can do all of it. IAC allows you to build, change, and manage your infrastructure in a very safe and consistent and repeatable way. Okay. And the main cherry on the cake is that it is very human readable language. It is a declarative configuration files. It's a very human readable language. You can simply just go through a Terraform file and you'll understand, even though you're not at all familiar with the Terraform concepts, right? So let's go to the next slide. Now there are different kinds of tools for IAC. Okay, that is infrastructure as a code tools. So let's go through all of them each, and then we'll further deep dive in one of the infrastructure as a code tool, that is Terraform. So IAC is supported by a variety of tools that enable the automation and management of infrastructure through code. So here are some of the types of IAC tools. The very first is configuration management tool. These tools are primarily focused on maintaining and configuring the state of servers and softwares. The examples for configuration management tools are Puppet, Chef, and Ansible. Okay. Next comes the orchestration tools. So orchestration tools are used to automate and coordinate the deployment of infrastructure applications across multiple servers or cloud instances. These are the tools like Kubernetes, Docker Swarm, Apache MES fall into this category. Now, you all must have used Kubernetes or Docker at some point, right? So those are called as orchestration tools. Next comes the server templating tools. So these tools allow you to create and manage infrastructure by defining templates for service or virtual machines. The examples for these are AWS CloudFormation, Azure Resource Manager. These are cloud specific. And HashiCorp Packer is more general purpose tool. Last but not the least comes the infrastructure provisioning tool. These tools focus on creating and managing infrastructure resources in the cloud or on premises. Terraform and AWS CloudFormation fall under this category. Here comes our very own Terraform that we are going to learn today a lot, right? Now that we have explored these different types of infrastructure as a tools, let's delve into why Terraform stands out and why it's popular choice in the IAC landscape. Okay, let's proceed further. What is Terraform? So before jumping to that, I would like to know that what are the tools that we covered in the past slide? Can you all add it in your comments? Folks, we want it to be a very interactive session. So yes, please put on your comments. Otherwise, I'll start feeling sleepy. Oh, we have a very good audience. We're getting a lot of answers. That's really amazing. Yes, Docker, Kubernetes, Chef, Puppet, CloudFormation. Yes, we have a lot of answers. Yes, yes, keep them going. Yes. Discussed the world without Terraform, the challenges that we would get. Okay. Then we discussed the different types of IAC, infrastructure as a code tools, some instructions to be followed. If possible, be on camera. Keep yourselves muted if you're not speaking, and put your questions in the chat, or you can raise your hand while speaking. So we'll definitely try to address your queries. Now, let's proceed further. So, what is Terraform? So Terraform is an infrastructure as a code tool that lets you define both cloud and on-prem resources in a very, very human readable configuration files. When we'll go through the hands-on, you will understand that those are so readable, like even if someone who is not from the coding background can understand those files. You can then use a consistent workflow to provision and manage all your infrastructure throughout its life cycle. We'll also go through the Terraform workflow in a short time. Terraform can manage low-level components like compute, storage, and networking resources, as well as high-level components like DNS entries and SaaS features and all. Okay. So how does Terraform work? Can someone think about it? How will this Terraform be working? Or what would be the workflow? If anybody is aware, they can share it with us. You can put it on chat. You can unmute yourselves and talk. Anything is fine. Okay, no worries. We can go forward. So how Terraform works? Terraform creates and manages resources on cloud platforms and other services through their application programming interfaces, that is APIs. Providers enable Terraform to work with virtually any platform or service with an accessible API. As you can see, we'll be writing some configuration files. There'll be providers inside that. These providers will be hitting the target APIs and bringing you the data that you want, right? Proceeding further. So, this is how the Terraform workflow is. This is the core Terraform workflow, which consists of 3 stages. The very first is write, plan, and then the apply. What does write do? In the write stage of the workflow, you will define resources. That comes the coding part. Okay. Which may be across multiple cloud providers and services. For example, you might create a configuration to deploy an application on virtual machines in a virtual private cloud VPC with security groups and a load balancer. Or you may create an S3 bucket for uploading your sorry for uploading your files, right? Or you may create DynamoDB tables for storing data in the database, whatnot, right? You can do almost everything. You can also create local files in your own machine as well. Everything can be done by Terraform. Next is the plan. Terraform creates an execution plan describing the infrastructure it will create, update, or destroy based on the existing infrastructure and your configuration. So this plan is You can see the plan in the Terraform state file as well. We'll talk about the Terraform state file in very soon, in a couple of minutes. But before that, imagine this plan like a to-do list that you create, right? So as soon as you finish a task, you check mark it that this is done. You again won't go and do it, right? Similarly, this plan will give us an outlet of what is going to happen when you run the apply command, that is Terraform apply. What are the resources it will be adding? What will be their names, their details, and everything. So say, for example, you want to again recreate those resources. You won't have to manually go to the UI or whatever you're using, whatever tools you're using to create the infrastructure. Instead, you'll just run Terraform apply and a new resource will come up like this in few minutes. Isn't that amazing? Finally comes the apply stage. So on approval, it'll ask for your approval. You have to type a yes over there once you do the Terraform apply. Then only the Terraform will go and deploy the resources that you have defined in the right stage of the workflow. Okay. So Terraform performs the proposed operations in the correct order, respecting any resource dependencies. For example, sorry. So let's take a simpler example than talking about the VPC. Now you are creating a S3 bucket. Okay, S3 bucket is like a virtual drive, you can say, where you can store your files. All right, talking in a very simple layman term so that whoever does not have knowledge of AWS also can understand. So this S3 bucket is your drive. Can you and there's a file you want to upload. Say its name is my first workshop on Terraform.txt. Okay. Now, can you create this before creating the file? Is it all right to upload it to the S3 bucket? No, right? The Terraform will say that the file does not exist and I cannot upload it to S3 bucket. So that is why these dependencies as well, you don't have to take care. Terraform itself take cares about all this, right? So isn't that amazing? You don't have to worry about any dependencies. Everything will be taken care by the Terraform itself. Okay, awesome. So this was the right plan and apply workflow. So before going to why use Terraform, can anyone tell me what were the 3 stages of the Terraform workflow we talked about? Can you put it on the chat? Yes, write, plan, and apply. That's great. I think everybody is very active and I really love that kind of audience. Thank you very much for being an amazing audience. And I hope this stays till the last of the session. Amazing, amazing. Okay, let's proceed further on why do we use Terraform? All right. So the major 3 advantages of using Terraform is it provides infrastructure as a code. Second is multi-cloud support and multi-platform support. Third is plan and apply workflow. Okay. Let's go through them one by one. First, let's talk about the feature of the infrastructure as a code. So Terraform's core strength is its ability to represent infrastructure as a code. This means that you can define your infrastructure, including servers, networks, and other resources using a simple and a very declarative language. By doing so, you treat your infrastructure just like any other software code. You may be working on so many coding languages, right? Java, Python, when you build your applications. So consider this as a language used for building a infrastructure, right? It is very easily understandable, maintainable. So this approach streamlines infrastructure provisioning, configuration, and management, reducing the risk of errors and ensuring consistency, right? So this is the very first advantage. Let's go to the next one. Next is the multi-cloud support and the multi-platform support. So Terraform is cloud agnostic, meaning it can be used to manage infrastructure across a wide range of cloud providers, such as AWS, Azure, Google Cloud, and whatnot. You name the platform and Terraform will be able to support you over there. It's also versatile enough to manage on-premises infrastructure. Isn't that great? So this flexibility allows organizations to avoid vendor lock-ins, optimize cost, and choose the best platform or cloud for each specific use case. So based upon your use case, you can switch platforms as well, switch the cloud providers as well. So that's the really amazing feature of Terraform. You can just lift and shift. Sorry, I'm having a little bad throat today. So please bear with me on that. Next comes the plan and apply workflow. As we all saw the plan and apply earlier as well in the Terraform workflow, let's again reiterate. Plan and apply plays a very critical, plays as a very critical advantage. So before making any changes to your infrastructure, Terraform generates an execution plan. So this execution plan gives you a very good insight on what is going to be added, what is going to be updated, and what is going to be changed, modified. It shows you that as well. So it is very good thing that when you are deploying on prod or higher environments, this really helps you. This plan will help you validate whatever you're going to do so that there are no last minute mishaps happening when you deploy anything to your prod environments, right? So once you're satisfied with the plan, then only you have to apply. So you'll have the confidence while deploying any applications that, okay, I have verified the plan and I think things will go as it is planned, right? So these are the three advantages. Makes Terraform a powerful choice for infrastructure as a code, providing efficiency, flexibility, and safety when managing infrastructure resources. Now, yeah, we come to the very interesting part, that is getting started with Terraform. As soon as we'll do this, we'll soon have a hands-on exercise as well. So that'll be really exciting for every one of you. Before proceeding further, let's have a quick question and answer so that we know that we all are, taking away things that are being thought over here. Okay, this will really help you in recollecting things back when you are out of the workshop and you want to use Terraform in your projects or day-to-day assignments or your personal projects, right? So can you put the topics that we covered until now in the chats? Let's take a quick minute for that. What are the topics that we covered until now? Yes, why Terraform before IAC? What is Terraform? Why use it? Different stages. Yes, that's amazing. Yes, we did. What is Terraform?
Hi, Kinnari. This is Jyoti. I have one question. I don't know whether I'm asking it correctly or not. Just I want to understand more. So you told that like it is vendor lock-in, right? So based on the vendor. So my question is like Terraform uses configuration files and the resources in Azure, or if you take two different vendors, Azure and AWS, the resources will be different, right? So how the same configuration file will be maintained for the resources in Azure and AWS?
Yeah, you'll have to do a little bit of tweak. It will not be completely lift and shift, but you won't have to affect your application anywhere, right? The Terraform will take care about that. You will change the providers and a little bit of shift and lift over here and there. That's all. Not like completely copy pasting, but yeah, a little sneak peek will be required, tweaks will be required, but other than that, it's very simple. Now, for example, if everything was manual, just imagine the pain of creating all your for infrastructure architecture, right? It is not like one EC2 machine or one load balancer or like that, right? You have a very vast architecture inside that. You'll have n number of resources that you're using. S3, DynamoDB, load balancers, auto scaling groups, and all those things, right? So, when you will use Terraform, that is infrastructure as the automation tool, it'll be comparatively easier than manually shifting all of your infrastructure.
Okay, thank you.
I hope that answers your question.
Yeah, thanks.
Awesome. Yes, I saw the answers. That's really amazing. We got a lot of answers and really good response. Let's switch to getting started with Terraform. Okay, a quick hands-on over here. So does everyone have the Terraform installed in your machines? Can we get a yes? Okay, awesome. Sandeepan has installed. Naveen has installed. Okay, awesome. I think everybody has installed, so that's really nice. I'm sure you'll enjoy today's hands-on. For people who have not installed, I'll paste the installation link over here. You can install it, and if you still like not don't want to install it, that's completely all right. We'll go through each and every example over here, and at the end of the workshop, I'll be sharing the Git link as well. So don't worry about that. You will not be missing out on anything. Awesome. So, before proceeding to the exercises, we'll first go through the building blocks of Terraform. Okay. We'll go through a sample snippet of the code, and then I'll explain each and every block, and then we'll proceed further. All right. So, as you can see over here, this is a Terraform code, which will set up the necessary configuration for an AWS provider and define an EC2 instance resource with specific attributes and tags. This resource can be used to create an EC2 instance in the specified AWS region with the provided settings. Let's break down the block into 3 parts. The first is Terraform configuration block, second is providers, and third is the resources. Okay. So let's first talk about the Terraform block. So in this Terraform block, it contains the Terraform settings, including the required providers. Terraform will use to provision your infrastructure. For each provider, the source attribute defines an optional host name, namespace, and a provider type. Terraform also installs providers from the Terraform registry by default. So in this example configuration, the AWS provider source is defined as HashiCorp AWS, which is shorthand for registry.terraform.io HashiCorp AWS. Okay. You can also set a version constraint for each provider defined in the required provider block. Okay. The version attribute is optional, but we recommend using it when you are like very pragmatic about the version that should be used. It should not be greater than this version, or it should not be less than this version. So all these constraints you can define in the Terraform block. Now, let's go to the next, that is providers. So in the provider block, you configure the specified provider. In this case, it is AWS. And after like you write provider, and then in the you'll add the AWS as a provider. If it is Azure, Azure will be there. If it's GCP, GCP will be there. Okay. Now, a provider plugin that Terraform uses to create and manage your resources. The provider here, we have mentioned AWS. So the Terraform will go and create all the resources in the AWS. Okay. You can use, yeah. And in the provider, you'll add the definition of the region as well. So here we have mentioned as US West 2. Whatever region you want to use, you can mention it over there. So all the resources that you will be creating as part of that configuration file will be created in the US West 2. Okay. Let's go to the next one. Resources. What are resources? So resource blocks are used to define components of your infrastructure like EC2, S3, S3 bucket object, DynamoDB table, IAM users, IAM user policy, role, and whatnot, right? Resource blocks will have 2 strings before the block, the resource type and the resource name. In this example, the resource type is the AWS instance and the name is the app server. Okay. So in the example configuration, Terraform manages the AWS instance resource with the AWS provider. Together, the resource type and resource name form a unique ID. For example, AWS instance.appserver.id will be the unique ID that will be formed. So whenever you want to access this particular resource throughout your configuration, you will use it in this. Let's go to the next one. So now what do we do next, right? We know how to write the code. We saw the blocks as well that are supposed to be mentioned. Now what is the next step? Next step is run the Terraform workflow. So in the running part, we have 3 things to be done. Okay. The very first thing is init, Terraform init. Then it is a plan, Terraform plan. Lastly, it is the apply, that is the Terraform apply. Together, init, plan, and apply form a fundamental workflow for managing infrastructure using Terraform. Okay. These commands ensure that your infrastructure evolves according to your desired configuration while maintaining the benefits of version controlled infrastructure as a code. Okay. Let's talk about Terraform init very quickly. So Terraform init, what does this do? It initializes a Terraform working directory. Like for example, when you, let's relate it with the day-to-day examples that we use. Say for example, you have a Git repository created. So very first time, what do you do? For making it a Git repository, you hit the Git init, right? Similarly, to make a particular directory a Terraform initiated directory, you have to do the Terraform init so that the Terraform will understand that this is the Terraform directory. Okay. Now, what else does it do? It will download any provider plugins that you have mentioned. It will initializes the working directory, which will help Terraform understand that in this directory we'll have the configuration files. It set up the necessary local states and backends. Okay. As soon as we'll hit the Terraform init command in our first exercise, you'll understand what is happening. All right. Next one is the plan. So what does the Terraform plan do? We have already talked about this, but again, I'll reiterate. Terraform plan will read your configuration files in the current state, compare it from the with the desired state. So plan will have the desired state, and whatever is not present, it will show as it will be adding these resources. You can see the output as well. And finally, comes the Terraform apply. So now the Terraform apply, it will execute all the changes that are there in the plan, be it creation, deletion, managing, whatever. Okay. Any updating, modification of any resources, everything will be taken care of Terraform apply. It is always recommended. Now, throughout the workshop, I'll be talking about the best practices as well while doing the workshop, hands-on and everything. So the very first best practice is, even though when we run Terraform apply, we get the whole plan that is going to be executed. Say, for example, EC2 instance is going to be created with following tags, following subnets, following VPCs, or a simpler example, a S3 bucket is being created. This is its name. It will modify this, that. So Terraform apply will also showcase the whole plan again. And then when you do a yes, it will run the execution. But again, it's always recommended to run the Terraform plan, understand what is going to be created, and then proceed further on the apply part. So this is one of the best practices. Now, yay, this is the best part of the workshop, hands-on. So what we'll do is, let's create a Terraform local file resource. So as you saw that AWS instance, AWS S3 bucket, AWS DynamoDB table, all these are resources. Similarly, when you want to do something in your local, this is the resource you can use. That is a local file. Okay. Once you will declare the local file resource, you will run the Terraform init plan and apply, and we'll see them in details. So are you all excited for the hands-on? Can we see some yeses in the chat? Awesome. I see a lot of yeses. That's really amazing. So let me quickly share my screen for the coding part. I'll share my screen. Is my screen through? You can see the IntelliJ. Ruba, can you confirm?
Visible.
Okay, awesome. So this is the Terraform Unleashed repository that I've created for all of you. Worry not, I'll be sharing the code at the end of the workshop, but not yet. Okay. So let's go to the local file part. This is the repository. You have the README as well. Here I've given the instructions how you can install Terraform, how you can verify that you're on the latest version. What are the basic commands that you will be using? Init, plan, apply, Terraform destroy. Terraform destroy is used for destroying whatever resources you have created. Now, even before doing the hands-on, I would like to tell you that Terraform destroy is a very helpful tool, very helpful command. Why? Say, for example, I've created a very big architecture for my test environment. Okay. It has like DynamoDB table, S3, EC2 instances, EKS, Kubernetes running. All those things are happening. Now, if I have to manually go and delete each of them, I'll be missing one or two. And that will in turn contribute to my costing, right? Not everything is in the free tier, right? When you're working on a project. So it'll increase my costing. Unnecessarily, I'll get a lot of bills, like a lot of dollars will be spent on that, right? So to make sure that you're not missing on anything, you should run a Terraform destroy. When you run a Terraform destroy, it'll again show you what all it will be destroying, and you'll have to give a confirmation saying yes, you want to destroy it, then only it will be destroyed. Okay. Then there are other two commands as well, Terraform validate and Terraform FMT. FMT as in format. Sometimes your Terraform files are not in proper format. So the indentation or the spacing and all those things, right? Simply run Terraform FMT and your formatting will be done. Simply run Terraform validate and it will check for any syntax issues that you have before you go for plan or apply and all those things. Then how do you run this? I've mentioned all those over here. I've given the additional resources as well. Trust me, Terraform documentation is a very good documentation. Whenever you want to like create a resource, you can definitely go to the documentation. Again, you won't be able to remember each and every attributes while creating all the resources, right? So that is why Terraform documentation is very helpful. As soon as you go to the documentation, type the resource you want to create, you'll get all the required attributes and the optional attributes given over there. And then you can seamlessly create your resources. Okay. Happy terraforming. Awesome. So the very first code is, now again, we'll talk about our blocks. Provider is local because I'm using my local machine only. I want to create a file in my local machine using the local file. Is the font too small? Is the font okay now?
Yeah. Yes.
Yeah. So since I'm not using any AWS or Azure or GCP, I'm just using my local provider right now. That is, I'll be creating resources in my local machine. That's why I've used the provider as local. Local file is the resource that I'll be using. And then this is the resource name. For local file, the compulsory attributes are file name and the content. Okay. As you could see in the slides, I've added that as well. I've added the link. The slides also will be shared with you as form of PDF. So don't worry about that. There's a link, Terraform. You can just simply type local file Terraform. So you'll get the resource over there. Okay, you can try it out now as well. So in that, two attributes are the compulsory attributes, that is file name and the content. Okay. So the file name is sample local file.txt and content will be congratulations, you just created your first local file. Now what is output? So say for example, you want to see what is the file name that got created, right? Even though you have mentioned over here, when you use the output command, it'll show you when you'll do a Terraform apply, it'll show you that file name is equal to this. How do you add the file name? This is the resource name, and the attribute. Okay. We just have to separate it with a dot. Similarly, like we do in the other coding languages. Similar to that, you can use it in Terraform over here like this. Okay. Now, I'll quickly go through the local file. Okay. You see there are no files over here. Folks, please pay a lot of attention over here because this is a very first configuration file that if we have created. Okay. And we'll be running and we'll be showing each and every basic step that happens while you run the Terraform configuration files. Okay. Right now, as you can see, there are no files over here other than the main.tf. Coming to this, Terraform files are declared as a .tf files. Okay. Whatever you want to add, output.tf, variables.tf. It has to have a .tf extension at the end. Okay. Now, what I'll do is I'll do a Terraform init. This was the very first command, right? Terraform init. Then I'll do Terraform init. See, it said it is initializing the backend. Okay. Finding the latest version. What did it see? Find the latest version of the HashiCorp local. Why did it go to local? Because my provider is local over here. Okay. It is installing its versions. Terraform has created a log file, that is Terraform log HCL. Now, as you can see over here, this is the Terraform log.hcl. Okay. So what this does is this will lock the version of the provider once you initiate the directory. So now throughout, when you'll be doing Terraform apply, this is the only version that will be used, so that there are no discrepancies or issues regarding moving from one version to another version. Okay. Because your code will be designed based upon this version, right? So these are the directories created. You can see the downloaded provider over here. Okay. So there are two files that got added when we did. Okay. Sorry for the delay. There are two files that are added, .terraform and the terraform log.hcl. Okay. We don't want to open that. Cool. So this is the log.hcl file created. Now, what is the next step, folks? What do we do in the next step? I have done the initiation. What is next?
Plan.
Exactly. Next one is the plan step. Okay. So we will do a Terraform plan. Cool. So when we do a Terraform plan, as you can see, changes to outputs. This output I had added as a file name, right? So this file name is given over here. This file name will be sample local file.txt. Okay. If I must have added output for content as well, the content also will be displayed. Now let's see this. Okay. So here you see the Terraform will be create. This is the operation create. I'm showing you how to read the plan. Okay. You can see Terraform will create operation is going to happen. What is it's going to create? Local file. Using the local file, it will create a resource called sample local file. Okay. What will be the content? The content will be congratulations, you just created your first local file. Okay. Now, so what is our expectation? A local file called sample local file txt will be created. Okay. Now, what is the next step? Can you add it on the chat?
Apply.
Yes, exactly. Next is the Terraform apply. So when we do a apply, again it will show a plan. I told you right before, but always it is recommended to run the plan first and then the apply. So when we do a yes, one resource is added. Then you see over here, you see the sample local file.txt, right? What is the content? The content is, congratulations, you just created your first local file. Okay. Coming over here, Terraform TF state. So this will store the TF state. Okay. Like what is the state right now? What are the resources that are created? See, the name of the file is given, the content will be given, and all those things. Okay. Now, we just added two attributes, right? But and the back end, there are different attributes being set. So all those you can see over here. Now you can see that the file permission is 0777. Now say for example, I want to change the file permission. What I'll do is I'll just mention this file permission parameter over here, add it here, file permission, and then I'll add whatever permission I want. Okay. That's simple as that. So just TF state is a very useful thing to use. And you can see every detail of the resources over here. Okay. Now what I'll do is I'll be on the main screen, main.tf. Okay. And I want you all to execute this on your local. Can you all do that? Or I'll just simply copy paste this code in the chat. Again, I'm going to share this code to you in the Git repository later. But for now, you can use it from here. Okay.
Kinnari, we have a question in the chat by Divya that provider is local means it will create file on the local file system.
Yes, yes. So provider local as in I wanted to create everything in my local machine only. For this, I'm using the local provider, and local provider block will be empty because you don't have to mention anything. You can check this in the Terraform docs as well. For the local provider, you don't have to mention anything. For AWS, when you will add, you will have to add a, say for example, I create this as provider AWS. So then I'll have to add a region over there. Okay, that's all. We'll do that as well. We have exercises here for creating S3 and DynamoDB and all those things. So we'll explain it at that time, but local means everything will be created in your local machine. So I'll just stop sharing my screen. And can you all do the hands-on? Once you are done, just put a thumbs up on the screen so that we can understand. Kirti, I did not understand. Is backend
Hey, yeah, so like we mentioned that there will be backend file and state file, right?
yes, yes,
So
that's
is
the
that
TF state. Yes, that's the TF state.
okay? Cool. Okay,
Yes.
yeah.
Okay. Um,
Kinnari, I have a doubt.
yes.
When we're mentioning Terraform plan, right? We haven't mentioned the file name as main.tf. Is that because in the directory we only have one configuration file and we don't have to mention the file name explicitly?
Yes, 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 exactly.
What if there are multiple Terraform configuration files
Yeah, the Terraform
in
takes
the
care about it. The Terraform takes care of that. It doesn't depend on the single file.
okay, even if we have multiple configuration files, we don't
Yes,
file
yes.
name exactly.
Terraform will take care about that. It will see all the configuration files and it will add the necessary resources.
Okay, okay, got it. Thank you.
Yes. Has everyone done it? Has everyone executed?
Hey, sorry, I missed. Like, where have you pasted the code? Okay,
The
chat.
chat,
I can
added
see it.
in the chat,
Cool.
yes.
Thanks.
Hey, I have one other question.
Mm-hmm.
So is it possible that after we apply, the status of the resource can change? I mean, s- so when we do a plan, we get a diff of what was the resource, what are the updates that are going to be done, right? And later, when we do an apply, is it possible that the difference can be, I mean, the diff be different because someone else
It can be. Again, this is a very good question. I'll talk about it when we are going to talk about Terraform, state, and state management. But again, this is a possibility that after doing the plan, if someone has changed something in the apply section, we'll get something else.
Correct. And would it be possible to actually lock or
Yes, yes, definitely we'll be talking about that
Sure.
in the coming slides in the state management part. Is that all right?
Yeah.
Okay. Has everyone done the exercise? You
I,
must not have CD'd inside. Can you go in, Ashish? Can you go inside the Terraform directory where you are and then do Terraform in it? Create a main.tf file. Awesome. Let's proceed further because we are having a time crunch. So now, what I'll do is, I'll share my screen again. Okay. Now what I did is, as you said, right, something changes. How does it get handled? So now I added a modify over here. Okay. Earlier, as you can see, the text over here is congratulations, you just created your first local file. Now what I did is I added a modify over here. When I run the Terraform plan, it will show you that the content has been replaced. Okay. Content has changed. So what we'll do is it will create it will remove the file and again create it. When you see Terraform plan and I do a yes, now when you'll see over here, you got the modified version. Okay. It's as simple as that. Cool. Now let's go back to the slides. Let me quickly share the screen again with the presentation deck. Okay,
Hey,
awesome.
so, like, while applying the new changes, right, we did not do Terraform in it. So, is it
Yeah.
just
So you don't have to do Terraform in it until and unless you're adding any provider plugins, as in adding any new resources. Okay. So how does adding new resources work? Say for example, I added one more resource over there. So our local machine won't have any data for that, right? So when you'll do a Terraform in it, it will bring those resources add those plugins basically. So these resources play as a plugin. Okay. Now, say for example, you want to use a certain app in your phone. Okay. You have WhatsApp. You want to use Facebook as well. So can you use Facebook without installing it?
No,
right?
yeah.
So
Hmm.
similar fashion, if you want to use some other resource, you want to add some other resource in the Terraform configuration file, you'll have to click on Terraform in it, so that it will download the provider plugins. Okay, those are called as provider plugins.
Cool. This helps. Thanks.
Yeah, no problem. So now we come to the part, how do we keep track of the resources created, updated, etc. Right? So the solution is Terraform state. State is the file that we showed over here, right? We saw the TF state file, we read it as well, okay? We saw that when we do a apply, a TF state file is created, right? So now let's explain the Terraform state as a shopping list analogy, okay? So here you'll understand the Terraform state very nicely from the shopping list analogy, okay? So a very short and real life analogy for Terraform state. Think of Terraform state as a shopping list. When you go grocery shopping, your shopping list, that is a Terraform configuration, specifies what items you want to buy and how many of each, right? As you shop, you check off items on your list as you put them in your cart. Okay.
Hello. Hi, Kinnari. Sorry to cut you in. There is a comment from Divya saying your voice is slow.
Okay. Is it better now? Hello, hello, hello.
Hello.
Is it better?
No, I think it's
Okay.
still the same.
Okay. Is it better now?
Yeah, we
Yes.
can hear. I can hear you.
Yes.
Okay, okay. Okay, dokie. I'm trying to speak at the top of my voice, but yeah. Just let me know again if there is any low voice or anything. Thank you for pointing out. Again, I'll just repeat what I said. So Terraform state analogy. Let's explain this in a very layman terms again using the shopping list. Okay. So think of Terraform state as a shopping list. So when you go grocery shopping, your shopping list, that is a Terraform configuration, specifies what items you want to buy and how many of each. Okay. As you shop, you check off items on your list as you put them in your cart. The checked off list, that is the Terraform state, shows what you have already picked and ensures you don't duplicate anything. Okay. If you make changes to your configuration, it helps you see what's left to buy and what's already in your cart, right? So just as your list keeps a track of your shopping progress, Terraform state keeps track of your infrastructure's current status, helping you manage it very efficiently. Okay. So again, what is Terraform state? Terraform state refers to the internal representation of your real world resources and their configurations that Terraform is managing. Okay. The Terraform state is the foundation of Terraform's ability to manage infrastructure. It serves as a database of resource information, a change tracking mechanism, and a means of establishing and maintaining dependencies between resources. So whatever dependencies, as I talked about it earlier, right? You cannot upload a file before it's created. So that dependency is internally managed by Terraform. And you can also externally define the dependencies using the depends on parameter. We'll see that later in this workshop in the hands-on. Okay. How will Terraform state help us? It will help us in resource tracking, dependency management, and output the information that whatever we are creating, we can just add it in the outputs and Terraform state will help us do that. Okay. Next is the hands-on time. Let's create an AWS S3 bucket using the Terraform resource. Okay. And here is a documentation as well. This is a documentation registry link. If you want, I'll just copy paste it and put it in the chat. Okay. I've added in the chat as well. And I'll quickly share my screen too for showing you the IntelliJ. Okay, awesome. We are here on my IntelliJ and let's go to the create S3. Before that, we'll just take a quick exercise for seeing the variables that are there in Terraform. Okay. So like every other coding languages, Terraform also has variables. Okay. So This is how you'll declare the variables. It will be in a variables.tf file. Okay. You have to mention variable followed by the name of the variable. Okay. In the variable, two things are compulsory, that is the type and the default. Type parameter and the default parameter. The type parameter will tell you what is the data type of the variable, and default will tell you what will be the default value for this. So say for example, if somewhere I'm using my string variable, the default value for it will be the hello Terraform. Okay. The number variable, then we have Boolean, then we have my list. So in the list, you can just put it as list with the string. This is a string list. So EC2, S3, DynamoDB. Then you have maps. So you can add a map as well. In the map, you can put the value like file name, file from map variable.txt, content, and as many keys as you want. Okay. Similarly, we have set. Similarly, we have object and so on. Okay. So this is the main.tf file. What I'm doing is I'm simply adding the output variables and I'll be seeing the output of those variables. Okay. Quickly, let's do a demo on that. And I don't want you all to again do it because then we'll miss out on the important exercises that we have. I'll just simply show you. We'll do a Terraform in it. Okay. We'll do a Terraform plan. And when we do a plan, it is showing over here. See. These are the outputs will be added. What will be the file name for map? As you can see in the file name we had added, right? For the maps. This is how we can verify. Sorry, it's here. So you can see file name is file from map variable.txt, right? So this in the main file, I'm doing the output, and here in the output I had given the name as file name from map, and the value was local file.sample local file name. Okay. Now when I do a Terraform apply, you will see the output of each variable over here. See, as you can see over here, all the variables that we had defined is present in this outputs, right? So you can use all these variables. Again, I'll share this code so you can do a hands-on on it at that time. Now let's quickly go to the S3 so that you all will be seeing how we are adding the AWS provider. Okay. Let's go to the S3 and I want, once I do it, you can also do it. Yeah. So let's have a quick walkthrough. I'll increase the font. Yes. As someone was asking me, when you add a provider AWS, what was the meaning of local, right? So now I'm using a provider AWS because I want to create a file on S3. Okay. I've added the provider AWS, region as US East 1. I want to create a bucket in US East 1. Now I've added the resource AWS S3 bucket, and the bucket resource name is example bucket. The actual bucket name may be my first Terraform bucket, and I've added a prefix over here because in AWS the buckets have to be have a name which is globally unique. Okay, you cannot have repetitive names. That is a law by AWS. That's a rule in AWS. So you can add some prefix so that you're not creating a duplicate bucket. Otherwise, Terraform will give you an error saying you cannot create the bucket already exists. Okay. Now the second resource is AWS S3 object. Okay. And we have given the name of the resource as example object. Now you will see a parameter over here called depends on. Why depends on I've added explicitly over here is because I wanted to show you how we use the depends on parameter. So when you add depends on, what will happen is first this resource will be created. Until then the S3 object won't be created. Now what is this object? Because in order to upload this file, I have to have a bucket at least, right? Without having the bucket, how can I upload the file? Correct? This will be like installing an application without the phone. I cannot install, right? That is not practically possible. Similarly, before having the bucket, I cannot put this object in the bucket. So that's why we have added a depends on parameter. Okay. Now I want you all to copy paste this. Can you all try writing this? Because your IntelliJ will give you suggestions as well. Try writing it once, and until then, I'll fetch my programmatic access keys. Can you all write that code? I've shared the link in the chat as well, so you can refer the registry, documentation registry as well. And until then, I'll add my programmatic access. So all of you are able to access your AWS from your CLI. Have you configured the AWS credentials? Can you please put it on chat? Yes, no, whatever you have done. Hello, hello, hello. Okay. AWS, no. Okay. You all have an AWS account. Do you have an AWS account? Because that was one of the prerequisites. Even if you don't have, that's fine. You can just look through the demo and then do it later, because you can do it yourself later as well, because this is a very easy this thing. You don't have to worry about that. Don't worry if you don't have the access. You'll simply do it on my machine and then you can do the hands-on later. When you have the Git repository link, all the code will be there. And the README also has all the instructions that you can follow. Okay. It has a link as well to configure the AWS access credentials. I'll put the link over here in the chat too, if you want. 1 minute. For creating your, having your own programmatic access, this is the link. The recording will be available on YouTube, Sejal. It will be done in the couple of days. By next week, it should happen. Yes. So I have my credentials configured now. So it's very simple, folks. I've sent the link on chat. This is the repository. This is the how would you get the programmatic access link. You can go and configure it from there. Okay. Now let's go to the main code again. So now what I'll do is I'm inside the create S3. I've added my access keys and everything. I won't be showcasing that in the recording over here. I'll do a Terraform in it. Now, can you note something? Can someone tell me what is the difference from the Terraform init when we did in the local file? Installing AWS. Yeah, it can.
Yeah.
Exactly. It's adding the provider called as HashiCorp AWS, right? I did not have to mention anything explicitly because I'm not concerned with the code as well right now, correct? The version, I'm not concerned with the version we'll be using. Any latest version is fine. So what it'll do is it'll just by default downloading the latest version, that is HashiCorp AWS. Okay. So this is how the provider will be changing as soon as you change the parameter over here. Okay. Now what I'll do is I'll run the Terraform plan. Okay. So the plan is running. It'll take some time. It says it'll add two resources. Okay. What it is going to add? Let's see over here. It'll add the example bucket with the bucket name as my first Terraform bucket. And it'll add a tag to that bucket. Okay. Next is it'll create an example object that is in S3 bucket. You will be adding your file. That file is simply called the object. Okay. And the key name will be my first file. And inside that, there will be a file called sample.txt. Okay. What is there inside the sample.txt? A small text that we have added. Okay. Now, what I'll do is I'll do a Terraform apply. I will confirm and okay. I'll just change the bucket name. I must have run it earlier. I'll add QWERTY over here. Okay. Now I'll do a Terraform apply. I'll confirm. Okay. I'll have to add it in other places too, in the tags, as well as here I won't have to, here also I'll add it. Now let's first do a plan. Terraform plan. And we'll see that the name is updated. My first Terraform QWERTY QWERTY everywhere. Yes. Now we'll do a Terraform apply. Okay. Yes, I want to create the resource and it is creating. Can you see over here? It is first creating the bucket because we have given the depends on tag. Until and unless the bucket will be created, the object won't be created. Okay. I'll let it create. In the meanwhile, I'll go to the AWS console so that I can show it to you. Okay, I'm going to the management console. Yeah, I'm in the region US East 1. Okay, awesome. I'll again quickly share. Yes, I'm here. I'll go to the login and here I'll search for S3. Okay. While doing so, as you can see over here, my first Terraform QWERTY is over here, right? When you go inside, there's a key folder called My First File. Inside this, see, you can see over here, right? Now what I'll do is I'll open. Okay. So when I'll open, this is downloaded and you can see the content over here. Welcome to Terraform Unleashed workshop. Congratulations on deploying your first local file. Correct? Cool. Now again, let me go back to my IntelliJ. Okay. So now I want you all to do it. Okay. Can you all do that? Yes. Can you all try doing it? Okay, you cannot. You don't have the S3 bucket, right? Okay, cool. We can proceed further then. I'll quickly share, go back to the PPT. I'll share my screen. So, folks, before proceeding further, were you able to understand this? Are there any questions that you have or anything? Even though you're not able to do it right away, but you can definitely refer to the recording and the Git repository and the README over here in the Git repository and do it later. But can you please give me a confirmation that you are understanding, you're following up? Awesome. That's really nice. Let's proceed further. So, okay, this was one of the exercises that I wanted to do. That is, I wanted you to create a local file resource, then create an S3 bucket. With a local file, you should have uploaded that local file to the S3 bucket. So we wanted to see that, okay, how is that happening, that flow, right? Yes. So this was the exercise. Maybe you can take this as your homework and do it when you have the AWS programmatic access. It's very simple, folks. The link that I've given you will help you get the programmatic access. Okay. For the assignment, I can quickly share the. Okay. No, I won't share the assignment. I want you all to do it. I won't share the code, but yeah, in the Git repository that I'll share, you will have the code over there. So you don't have to worry at all about that. Okay. Now going to the next one. Where should we, okay, we have a question. Okay, credentials part. Yes, exactly. I could not showcase the key that I was adding, but Raghu, when you go to the link that I've shared, no, in the chat, I've shared a link, right? So in that link, you have the steps in order to configure your credentials. Okay, let me show it to you quickly over here. Can you see this? Managing access keys for IAM user. So when you have your AWS account, what you have to do is you have to go to the settings part here. In your very right corner, you'll have this. You'll go to the security credentials and from there you can download your access key. After getting the access key, It's very simple. You just have to add your access keys and the password, secret access key in your terminal. The steps are all given over here for doing that as well. Okay, how you will add your access key and everything. Once that is done, it will automatically contact your AWS. Does that answer your question? Okay, awesome. And still, if you have any questions or anything, you can reach out to me on LinkedIn or Meetup or wherever. You can put your message and I'll try resolving your issues. If it is like, if you are from ThoughtWorks, you can simply message me on GChat. I'll be really happy to help you on that. All right. Any other questions? If not, we can proceed further. We're good, right? Okay, I'm back to sharing my screen. So now, folks, I want your inputs on this one. Where should we store the state files? Can you please tell me? Where should we store the Terraform state files? Can we store it in the version control? Where can we store it? Can we store it in the version control? S3, some of you are telling me S3, yes. Yes, for the second hands-on. Yeah, Ashish, I'll share the link as well, the Git repository link at the end of the workshop. Is that okay, Ashish? Okay, awesome, cool. Yeah. So moving on. So Terraform state, like, okay, before going to the S3 part, I know that Anusha, you gave a really good answer that S3, you can store the Terraform state in your S3. But before that, can you all tell me why cannot we share it in the version control system? Any idea? Everyone? Any idea why cannot we share the Terraform state file in the version control? Okay, if not, I can tell you. So, no, storing the Terraform version in the state file is not at all a good idea. Why? I'll tell you that as well. Because first, there will be a manual error. Okay. It will be too easy to forget to pull down the latest changes if you have in the version control. We often do that, right? We do not take a pull and we directly do a push. So that will create a lot of chaos. There will be no locking, right? The Terraform, when you add the TF state in the version control, you cannot prevent from two members writing at the same file at the same time, correct? Secrets. Now, Terraform state file will have the secrets in plain text format, okay? So that is called as a sensitive data, right? When you will create EC2 instances or, you'll have your access keys over there, right? For the EC2 instances and all those things. So that is stored in the plain text format. If you added this in a version control, this can be a security issue, right? So that is why using this Terraform TF state management in the version control is not at all a good idea. Okay. And there comes the Terraform state management. Now, how do we manage it? Yes, as rightly said by Anusha, we can use a remote backend. Okay. So today in our workshop, we're going to use a remote backend called as S3. Okay. So how does this work? How do we store the Terraform state then? Instead of using version control, the best way to manage shared storage for state files is to use Terraform's built-in support for remote backends. Okay. It has a built-in support for remote backend. You just have to simply add a backend code and you'll get sorted. Okay. A Terraform backend determines how Terraform loads and stores states. The default backend, which you have been using the entire time, is the local backend. As you all saw, right? The local backend is in your Terraform directory itself. The Terraform TF state file was you stored, right? Remote backends allow you to store the state file in a remote shared store. A number of remote backends are supported like Amazon S3, Azure Storage, Google Cloud Storage, HashiCorp's Terraform Cloud, and Terraform Enterprise. All these are remote backends. In today's workshop, we'll be using the S3 as a remote backend. Before proceeding further for showing you how we'll configure that remote backend, let's first look at the best practices. Okay. So the very first best practice is organize your code. Organize your code logically into modules, files, and directories. Let's not talk about the modules right away. I'll talk about modules. That is a complex topic in Terraform in a later stage. Okay. But files and directories. Name your files accordingly. Like you have, say, for example, main.tf, you have variables.tf. Then, as we had shown the output in the same configuration file, right? Instead of doing that, you can also have a outputs.tf file as well. So this organization will help the other person also to understand what is going on. So that is one of the best practice. Second best practice is use variables and outputs. Of course, when you use this, if you don't use variables and outputs, your code will look very cluttered. Say, for example, in this S3 bucket code that we showed, we use the bucket name like two or thrice, right? Once in the bucket, actually in the bucket, then in the tag, and then thirdly, in the place where we were using the bucket name, right? So if I have the bucket name in, if I have the bucket name in the variable itself, I can simply use that variable. So my code will look a lot cleaner, right? That is one of the best practice. Next is add comments and documentation to your code. That is also very good practice so that when the other person comes up, they'll know why you had done a certain thing. What is that certain thing, right? That is we follow in any application coding as well, correct? Lastly is the state management. Use remote state storage when there are more than one people working on a project. Even if there is two people working on a same project, please use the remote stage management so that there are no conflicts in your infrastructure or no unwanted mishaps that happen. Okay. Now, again, we have the hands-on time. So here what we are going to do is we are going to configure a remote backend. Now, if you want to on how is the 1 minute, I'll share it with the meeting group. Here is the link. Okay. So let me quickly share my Intel IJ and I'll show you how to configure the remote backend. All right. Yes. So this is the S3 Terraform backend code. Okay. You see, I have not initialized anything, right? This is the S3 backend bucket. Okay. And here what I'm doing is there's one more resource in Terraform called as time static. What this will do is it will give me the current time. Okay. You don't have to add any required parameters over here. There are no attributes that are required in this. You can simply do the add this block and you'll get the current time. Okay. What I've done in the output is I've outputted the current time. Okay. This is how you'll output it, right? Time static dot current time. That is the resource name. This is the resource type, resource name, and the ID. Okay. Now, in the variables, I've given the backend bucket name. Okay. My first Terraform bucket 3299. Okay. Backend bucket key. That is this will be the key. And inside that, it will store the Terraform TF state file. Okay. Now, here you go in the output. Here is the main. Okay. So let me quickly just check my AWS console once, and then we'll get started here. And after that, we'll take a quick break. So don't worry about that. Okay, cool. We are good to go. So I'll quickly bring my screen up. So now I'll go to the Terraform backend folder. Okay. I'm here. I'll just clear this out and do a Terraform in it. Now, you have to observe that this is the backend block that we have added. The backend is S3. What bucket will be uploaded to? What will be the key and what will be the region? Okay. Now, when I do a Terraform in it, what happened? Okay. Let me what happened to this? Maybe it was not allowed. What did I miss? Oh, okay. Just give me a minute. Okay, we cannot give the variables here. It must have some constraints. So what I'll do is I'll simply replace with the actual names and try that out. Okay. This will take just 1 minute. Just a minute, folks. So sometimes there are some attributes wherein some resources where you have to follow certain things, and this would be one of them maybe that you cannot, you know, add the variables. You have to add the actual names only. So we've added the names over here. We just quickly do a plan. Okay, awesome. I think we are good. I'll just share my screen again. Okay, now let me do a plan. Okay. So when you do a plan, as you can see over here, time we'll output it. When you do a Terraform apply, we'll see the output. Okay. This is the resource time static and the current time will be added over here. Okay. As you can see over here, see, initializing the backend. This is the part which I wanted to show you. Okay. Initializing the backend. Successfully configure the backend S3. Terraform will automatically use this backend unless the backend configuration changes. So as you see over here, when you do a init itself, that time itself, it will tell you that the backend will be S3. Okay. Otherwise, the backend was local. All right. Now let's do a Terraform apply quickly. We'll say yes. So as you can see, the output time we have given over here. Okay. This is how the you can log some time. So for example, you want to log that when this particular resources were created and all those things. So then if you add the time variable over your time as an output, you can see this in your configurations that, okay, this was the time this was created. Now, let's quickly go through the Terraform bucket. So this is the bucket, right? This is the bucket. We will do a refresh. Okay, let me refresh this. Yes. As you refresh, you see the folder here, stored TF state. And inside this, when you will open, it will be downloaded. See, this is the TF state, right? Can you all see this, folks? Is the Terraform state visible to you? So,
Yes.
you understand, right? How do we configure the remote backend? So now what will happen is you simply keep on coding your infrastructure resources part. Your Terraform state will be stored in the remote itself. So you don't have to worry that, okay, when you are working, someone else will work on that and you'll create any chaos or anything, because this remote backend will be fetched from the S3 bucket. All right. You can create policies where no one can modify those objects and all those things. That is the part of AWS. We won't talk about it right now. But yeah, this is how the Terraform remote backend works. Okay. I'll just stop my screen and I think we are on time. We can take a short break. Do you all want break? Everyone? Yes. Okay. Awesome. Cool. Uh, so how much time we can take? We can take about it's 11:37. Let's come back at 11:47. Is that okay? Yes. No. Okay, it works. Cool. I'll just stop sharing my screen from everywhere and let's be back. Don't leave the Zoom. You can be honest. And again, open for the doors of Terraform. Yeah. So, folks, before proceeding further, I would like you to go through the feedback board and add your feedback. Let's take a 2-3 minutes for that. Until now, how was the session? How was the hands-on? How did you like the explanations, the analogies? Whatever you feel like, you can add it over there, please. I've pasted the link in the chat. The link is accessible, right? We have a very small section. I mean, it's a complex topic, but then I'll try to make it as easy as possible for you all to understand. And then we'll do a hands-on. And then we have a best practices slide. And then we are all done. Okay, awesome. So let's go through. So I have some questions, okay? If you all can please help me answer those. So how do we create infrastructure components in such a way that, we can reuse them across multiple projects, environments? We have different environments, right? You all must be working somewhere or the other where in the project, wherein you'll have like a devil environment, qual environment, cert environment, prod environment, pre-prod, staging, whatnot, right? And everywhere we try to make the infra, the code, and everything as same as possible so that we get the issues very early in the cycle itself and not wait for the production issues to be coming, right? We started the recording, no? Okay, cool. So, can you all tell me how can we do that? Any idea? Any suggestions? Anything is fine. Wrong answers are also most welcome. I would say that no answer is a wrong answer, but at least it's an answer, right? So
We can create a catalyst project where all the components will be, I mean, um, we can pass as a variable as per the requirements.
that's really good. You're going on the right track. You're going on the track wherein you will get the solution for this. Yes. Anyone else? Okay. Uh, Thank you very much for that answer. So let's further analyze this problem. Okay. So this is like a very one resource that you're adding, right? So it's very simple to manage it. As you manage your infrastructure with Terraform, you will create increasingly complex configurations. And there is no intrinsic limit to the complexity of a single Terraform configuration file or a directory. So it is possible to continue writing and updating your configuration files in a single directory. However, if you do this, you may encounter one or like many problems, I would say, right? The very first problem will be understanding and navigating the configuration files will become increasingly difficult. Next will be updating the configuration file become more riskier, as if you updated one section, it may cause unintended consequences in the other parts of your configurations, right? uh, there will be an increasing amount of duplication of similar blocks of configuration. For instance, when configuring separate like dev, staging, production environments, which will cause an increasing burden when updating those parts of your configuration, right? You may wish to share parts of your configuration between projects and teams and will quickly find that cutting and pasting blocks of configurations between projects is very error prone. You may miss something and then that will create a lot of chaos. And to backtrack that also will be a very difficult task, right? we as a developer need more Terraform expertise to understand and modify your configurations like that, right? When you have like tons and tons of lines of code, it'll be very difficult for us to do that. So, what is the solution for that? The solution is Terraform modules. Okay. The solution is Terraform modules. So now, what are Terraform modules? So a Terraform module is a reusable package of infrastructure code that allows you to define and manage a specific set of resources and configurations. Modules promote code reusability, separation of the topics, standardization in your infrastructure code. They are like building blocks that help you create and manage complex infrastructure more efficiently, more easily. Okay. A Terraform module is like a set of Terraform configuration files in a single directory. So now the modules that we wrote, like the directory that we had created, that is also called a module itself. All right. But it's just that it's the root module. Now, say for example, what I'll do is I'll create a module for like S3 or DynamoDB. And then when I have to call it from like, I'll simply call it using the variations. Now for Devil, see, for example, I'm using DynamoDB table hyphen devil. Okay. For qual, I'm using hyphen qual. For prod, I'm using hyphen prod. I'll just send that name and other all attributes that I want to make a standardization across the environments that can be hard coded in the module itself, right? So that no other people can change those things. Say, for example, you have added some mandatory access, right? So that mandatory access will be same across all the environments. The person who is like reusing those modules or calling those modules cannot change those fixed attributes, right? So that will make our code more standardized. Let's go to the next slide and see what do these modules will do. Like we talked earlier, they'll help us in the reusability. Create once, use as many times as you want for your infrastructure. Abstraction. It will hide the complexity and provide a clean interface. Now, say for example, I'm working on a project. Okay. There I have 10 microservices. Each are creating DynamoDB table. So, as a DevOps engineer, for me, is it feasible to create 10 DynamoDB tables configurations everywhere? Maintain those configurations, the accesses, the primary, the hash keys, the primary keys, and the credentials and whatnot, right? So it'll be very difficult for me to manage that. So now what I'll do is I'll create a module and I'll ask the application team to do it self-service as well. The application also team also can take care of this by just calling that module in their uh, repositories, right? So this makes the life of a DevOps engineer so easier, correct? Just once you have to like take some time out, create a module, whatever restrictions you want to put into it, whatever the mandatory variables you want to put into it, everything is done. Send that module to the application team. They can use it with the required attributes they want, right? So simple. So this abstraction will really help you and hide out the complexity. The application team need not know what happened on the infra part, right? They just have to bother with the end result. So that creates a less chaos on the application team side as well as the DevOps people side, right? Next is the consistency. When you use modules, it will enforce standardized patterns and best practices, right? Organization. Keep code well structured and maintainable. When you have modules, you will see, we'll go through the example as well. That time you'll understand that how modules will simplify our code. Okay, not everywhere you'll have the repeatable usages of those resources, right? Next is the versioning. Now, when you create modules, you can create versions as well, which each module you can add like this is the 1.0 version. Next is the 2.0 version. Then when you're calling that module, you can simply use that version itself. So if you want to go to the previous version, you can do that too. And if you want to stay on the same latest version, you can do that as well. So this really makes the life of a DevOps engineer very, very, very simpler. So modules are like a boon for infrastructure management. Next is documentation. It includes usage examples and explanations for the user. So whenever you're using modules, it'll have examples and everything so that an ideal, like a person who has no background as well can understand those. Okay. Are we good on the modules part? Is everybody understanding what are modules?
Yes.
Okay, awesome. That's really nice. Good. Let's go to the next part. We have one more set of best practices here. Okay. So using a couple of best practices are using modules. The very first thing. Create and use modules for reusable components, promoting code reusability, abstraction, and encapsulation. Best practice is environment variables. Use environment variables to store sensitive information like access keys, secret keys, and all those things instead of hard coding in the code. That's why I did not cover the part itself where you hard code the credentials in the code and then create a S3 bucket or anything, the AWS credentials. Instead, you can simply export those variables in your environment variables. Okay. It is like export the environment variable name and the value. That's all. Okay. I've shared the link as well for that. So when you'll follow the documentation, you can have a programmatic access. So this is one of the best practice. Never ever store your credentials in any of the configuration files and not put it in the version control at all. Okay. Next is secrets management. Use dedicated secret management tools to securely store and manage sensitive data. Now, the other option is if you don't want to store it in the environment variables, say for example, you're integrating this code to your CI/CD. Okay. So now how do you store the credentials? Now the environment variables won't help, right? So how do you store the credentials? You'll store the credentials in your you have organization level secrets in the GitHub, right? You can store it there, or you can store in the secret manager service given by AWS. Okay. You can read about that more on the AWS documentation page, GitHub documentation page. But again, the best practice is never ever store your secrets in any of the files that are being version controlled. Okay, that's one of the best practice. Lastly, when you're storing your remote backend in the S3, have continuous backup of that. Wherever you store this in the remote backend, almost all the remote backends have a mechanism to take a backup. So always take a backup of your TF state so that you are not stuck when you are losing your TF state by some reason, be it accidental deletion or be it some security attack or whatever. So just make sure to take a backup every now and then so that you don't lose the state file. All right. Awesome. So you are at the final problem statement. You have completed all the essential modules, all the essential topics that should be done for the Terraform. And this is our big problem statement exercise. Now what will happen is we'll do this exercise, okay? And I'll show you each and every things that we did during the session from all the hands-on. All the knowledge that you've got throughout the session will be helpful in using while we do this problem statement, the final problem statement. Okay. The very first part for this problem statement is create a DynamoDB table. Okay. For those who don't know what is a DynamoDB table, it's basically a database. Okay. You just have to create a database. All right. If I explain in a very simple term, while you create this database using your Terraform configurations, you have to use appropriate variables, appropriate output files, add proper tags to your resources, and then run the init plan and apply the Terraform workflow. Post that, once that is done, what we'll do is now we have to create this for the devil colon prod environment as well. How do we do that? By using modules. And that's when we'll explain how modules are created and how we can use them. All right. Is everyone with me? A yes on the chat. Okay, awesome. Everyone's with me. That's really great. Let me share my IntelliJ. Just 1 minute. Until then, can someone recap until now what did we do? Folks, maybe you can unmute yourselves or you can put it on chat. Anything is fine. Can you all give me a recap? Just the high level. What topics do you remember? Topic name is also fine. You don't have to say anything precisely. I don't see anything in the chat. Can you start please adding, or is there anything you want me to reiterate or anything? You can just let me know that. Folks, are you with me? Okay, awesome. We are getting the answers. Yes. Where to start state file, Terraform modules, Terraform state. Awesome. Cool. Yes, that's what we did once we came back from the break. Okay. Now what I'll do is I'll go to the modules part. Okay, cool. Just give me 1 minute. Okay, I'll just share my screen. Continue. Okay, my screen is up, right? Okay, so this is the basic file that I've already created and kept over here. Okay, let's go through. Here is a provider block. Okay, then we have the variable table name. Okay, then we have the resource AWS DynamoDB table, and we have the resource name as example. We'll take the name of the DynamoDB table from the variable, that is, you can define variables in the same file too, but of course it's recommended to have a different file for variables because you'll have a lot of variables while you're working in your own project. This is just like a sample project, so that's why it doesn't have many variables. So here we have given the table name as example table without modules. Okay. Yeah. So what do we do now is we do a Terraform init. Okay, no, wait. I have to go inside the DynamoDB table without modules. Then I'll do a Terraform init. Now see, it's installing the AWS provider. I'll go further. Let's wait until then. So I'll explain the modules, the resource over here. So in this AWS DynamoDB table, we have the name of the table, the billing mode. The billing mode is like paper request that we have chosen. And there's a provision mode as well. Again, this is a AWS term. You don't have to worry about it. Next is the hash key. In the hash key, I am taking the hash key as ID. And what this ID will be like a number. Say, for example, you're creating an employee database. Okay. So you're adding the ID. Every employee has an ID, right? Employee ID. So I'm taking that ID as a hash key. Hash key is simply like a primary key. Okay. Type n type n means it's a number. And what is the environment? We're storing it for dev. Okay. So now let me do a Terraform plan. So when we do a plan, we'll get that, okay, one to add. All right. What it is going to add? It is going to add the AWS DynamoDB table. Okay. Now, what we'll do is we'll do a Terraform apply. We'll do a yes. It is creating. Okay, apply complete. Now let's go to the console. I go to the management console. And then we go to the DynamoDB table section. Okay. And then you go to the tables. So as you can see over here, example table without modules is created. All right. And you can see the ID as number, right? So this is how a table has been created. Now, what I want to do is I want this table for like all my environments. So adding this, like now, not just this, like for the three environments that I have, the devil, call, and prod, but I want it for each and every microservice that I have. Okay. Say, for example, I have 10, 15 microservices in my project. Okay. So I want these microservices also to have these DynamoDB tables. Now, if I add all these configurations manually, the app team can maybe change the hash key, maybe change the billing mode, right? How would I know that it is consistent across all the microservices? It is consistent across all the environments. How do I know that? And that is the reason, as a DevOps engineer, it will be very, very difficult, very, very daunting for me to maintain each and every file like this. So what I'll do is I'll create a directory called modules. Here I've added in the same repository, but usually in the ideal real world scenario, what we do is we create a repository itself for the module. Say, for example, uh, Terraform Aurora module, Terraform DynamoDB module, Terraform DB provisioner, Terraform S3 provisioner, anything like that. Okay. We create those kind of repositories and think that this module is a repository. Okay. Now, in this module, I have this DynamoDB folder mentioned. In this, I have a main.tf file. Okay. Now, what I'm doing is this name I'll be fetching from the client that is using. Okay. The application team that is using my module. Okay. This billing mode I've hard coded. The hash key I've hard coded over here. So nobody can change it, be it in whatever environment they are using, be it in whatever microservice they are using. Okay. Now, we are just accepting these variables, not giving any default values over here. So this will be like table name will be string, and the tags we are taking as a map. We can take multiple tags as well. That's why we have kept the thing as map. Now what I'll do is this is inside modules DynamoDB, right? Now go to the devil environment. This is the main file, right? Just main.tf. See how clean this looks, right? Doesn't it look very clean? Right? When you had seen this DynamoDB file and this main.tf, see, it has so much code, right? And this is just like a one DynamoDB table. When you're in a real world scenario, you have like n number of things happening, correct? N number of resources. So this, when it comes to the when you use a module, this will look a lot more cleaner. Okay. Now let me explain what this module is. Okay. This is the module, and you have to add the module name. That is the example DynamoDB. Now, the source. What is the source of the module? The source of the module is, like you go to directories back in the modules DynamoDB. Okay, we mentioned the path. Now I'm sending the table name. The table name is example table devil, and the tag is environment devil. Okay, this is what we are creating. Similarly, we have it in the call. As you can see, the call is mentioned over here. Other all things are same. Similarly, you have it in the prod. Okay. The source is mentioned, the table name is mentioned, and the tag is mentioned. Okay. Now what I'll do is I'll simply go to the devil first. Cool. I'm inside devil. I'll do a Terraform init. Sorry. I'll do a Terraform init. Okay. So it is initializing. All right. See, it said initializing modules over here, right? So it is also initializing the module, that is modules DynamoDB, which is here, right? Now it has done the initialization, all right? And now we'll do a Terraform plan. Okay, what happened? At least one attribute access, specify the resource name.
You didn't put inside double quotes.
Oh, okay, yeah. Thanks for pointing that out. Okay, cool. Let's do a plan. Okay, see, it adds one resource. I did not have to add any other parameters, and simply all other were taking as default that we have mentioned in the modules. Now we'll do a Terraform apply. When we do a Terraform apply, it'll ask for confirmation. Hooray, we are done. It says that apply complete, resource created 1. Let's go to the console in the tables. We'll refresh this and you can see example table devil is ready. Now, as we have not done anything in the destroy part, let's see that as well. Okay. Now, when you do a Terraform, okay. These are the couple of examples. What you can do is you can simply Terraform -- help and the command that you want to see, and you can get more answers, like more details of those commands. Like we have the help commands for all other tools also that we use, right? So say for example, I do a Terraform state list over here. So what will happen? It will tell me this is the resource that is there, okay, in your state list. Now what I'll do is I want to do a Terraform destroy. When I do a Terraform destroy, it will remove out the infrastructure. It'll ask me, see, it shows over here, it's destroy. Earlier, when we were creating, we saw the command over here as create, right? Here you can see destroy, and I'll type a yes, and this will be destroyed. When you go back over here in the tables, you refresh, it's gone, right? It's as simple as that. Now, okay. So similarly, when you'll do a apply for prod and call, you'll get the tables over there as well. Simply by this clean cheat code that is module, example DynamoDB, and that's all. You have to give the mandatory parameters and everything will be taken care by the modules itself. I have took a very simple example over here so that people who don't have the knowledge of AWS and stuff, they don't get confused. Okay. But modules on a higher level, when you use it in projects and all, they are very complex structures. But when you will see the use case, when the person who is using those modules, will be very simpler for them to use it, right? They'll simply call the module. Like we have source over here and we have mentioned the directory, right? In the real world, real project, we'll have a link over here of that particular GitHub repository of that resource, the module that you have created. Okay. I'll quickly stop share my screen and I'll share before going forward. Folks, do you have any questions? Okay. So we did this. We created the DynamoDB table as is, and we created it using the modules as well. Okay, I think we have a question. Okay, no, that's not a question. It's an earlier chat. Okay, cool. So are we clear on the exercise that we did right now, implementing the modules? Can I get a yes on the chat?
Hey, Kirti here. I have a question. So, like when we destroy, like what changes happens in the Terraform state file? It will means Terraform state file will be there, but it will remove all the associated resource information.
I'll show it to you. Yes, it'll remove everything.
Okay.
It's an empty file now. Okay.
Cool.
Yes. Any other questions, folks? If not, I'll again share my screen. We'll quickly see the last part. And I will need your help in this for the last part. Okay, takeaways. So folks, can you all tell me what were the takeaways for today's session? And it'll be good if you can come on video as well. Yeah. So that we have a couple of minutes and then we'll wrap up the session. If you all come on video, if possible. If not on video, if you can unmute yourselves and say like at least one takeaway from each of you. We can start like Yes, anybody?
Maybe I can start. So, like I've used Terraform in my projects, but I had some confusion related to modules. And yeah, thank you, Kinnari, for clarifying my doubts.
Yes, thank you very much, Kirti. And I really appreciate everybody's patience and the interaction that you all did. I had a really great audience today. So I really enjoyed uh, working with you all and, helping you understand the Terraform concepts, the easy topics, the complex topics, and trying to make it as simple as possible. Yes. I hope you all enjoyed, and I think you all have understood why you should use infrastructure as automation, infrastructure as a code. What are the Terraform building blocks? What is the Terraform workflow? Uh, Best practices you should be following. We try to cover all the best practices and lots of hands-on, of course. Yes, I've shared the repository. I'll again share the link over here. 1 minute. And when we'll upload the YouTube video as well, what we'll do is we'll have the repository link in the description as well. We'll try to do that. I've shared the source code again. Yes. And we come to the end. I think we have wrapped up early, so that's a really nice thing. We have stopped the recording, right? We can stop the recording now.